Today, we're diving into the story of the software that turned the world of digital design upside down. The story of Rhino. If you're an architect, an industrial designer, or even just a fan of digital design, you've probably heard the name Rhino, the software that turned designing complex forms, free-form volumes, and strange geometries into a delightful experience. But behind this powerful facade lies a truly strange story. A story that begins in the laboratories of Boeing, passes through the mind of an ordinary accountant who is passionate about automation, reaches an advanced math library called AGLIB, the beating heart of NURBS, and finally, the software's name was inspired by a 500-year-old painting by Albrecht Dürer. Yes, the birth of Rhino is an unimaginable blend of engineering research, individual creativity, classical art, and industry needs. Hi, I'm Hossein, and welcome to another video on my channel. The story of Rhino's birth is one of the most unexpected and fascinating narratives in the history of architecture and digital design. Imagine the late 20th century and the early 21st century, a time when architecture had grown tired of philosophical debates and complex theories, and everyone was looking for tools that were practical, precise, and fast. And that's when Rhino arrived. Not as a luxury software, not as a pre-programmed hero, but as an answer to a deep pain in digital design. This software didn't just change design tools, it changed design culture. Rhino turned the idea of parametric design from a fantasy into a serious movement. It made architects see themselves not just as designers, but as algorithm writers, digital builders, and technologists. And its impact is visible in major projects worldwide, from Frank Gehry's works to any project featuring freeform shapes and digital fabrication. In this video, I'll walk you step by step through its story. From that accountant who never imagined his software would shake the design world, to the complex journey of developing NURBS, to Rhino becoming one of the most essential tools for architects, designers, engineers, and digital makers. Are you ready? Let's go. This is a story worth hearing. Section 1, The Strange Beginning, an accountant who fell in love with automation. All right, let's go to the starting point of this unusual story. Picture this, the early 1980s. Personal computers, like the IBM PC, were just entering the market, and most offices were still running on calculators, paper forms, and endless manual paperwork. Our protagonist, Robert McNeel, better known as Bob McNeel to his friends, was not a software engineer, not a designer, not a CAD expert. No, he was a professional American accountant working in engineering and consulting firms. These companies managed huge industrial and architectural projects, but their accounting systems were still slow, traditional, and painfully manual. McNeel, armed with a degree in accounting, was constantly frustrated by repetitive, slow, mistake-prone tasks at his desk, long manual calculations, entering the same numbers into multiple spreadsheets, and preparing reports that took hours to complete. But the interesting thing about McNeel was this. He was naturally a problem solver. In the early 80s, when personal computers like the Apple II and the first IBM machines became accessible, McNeel began writing simple accounting software for himself and his colleagues. These small tools included macros, tiny pieces of automated code for programs like Lotus 1, 2, 3, the grandfather of modern Excel. These macros sped up work, reduced human error, and dramatically improved the entire workflow, automating financial calculations, preparing monthly reports, and handling routine accounting tasks. The result? Managers loved this automation. They encouraged McNeel to push further. That early spark led to the founding of Robert McNeel and Associates, or RMA, in 1980. At the beginning, the company focused on developing accounting and automation software for engineering and architectural consulting firms. But McNeel wasn't satisfied. He thought, if I can automate accounting, and make it more efficient, why can't I bring the same mindset to design and modeling? Around 1985, when his clients started using early CAD tools like AutoCAD, McNeel noticed they were struggling with the same problems: repetitive drafting work, software limitations, and a desperate need for smarter automation. And that's when McNeel stepped into the world of CAD. He eventually became one of the biggest AutoCAD resellers in the Western United States. But this was only the beginning. That simple idea, improving the workflow of designers and engineers, became the foundation for the birth of Rhino, a tool that would later spark a revolution in digital design. Section 2, the real problem, why Rhino was created, the rise of AutoCAD, and McNeel's entry into the CAD world. Now that the initial spark had formed in McNeel's mind, let's move forward and see how this idea slowly turned into a real product. Imagine the 1990s, a decade of explosive digital growth. Personal computers from companies like Dell and IBM were everywhere, and CAD, computer-aided design, was transforming the design world. In the middle of all this, AutoCAD, created by Autodesk, hit the market like a bomb. It had been released in 1982, but its golden age truly arrived in the 90s. According to historical reports, by 1989, Autodesk controlled more than 60% of the PC-based CAD market, with revenues reaching $117 million. By the early 1990s, AutoCAD held over 50% of the global CAD market, and DataQuest reported that about 24% of the worldwide PC CAD market belonged to AutoCAD. Everyone wanted a copy. Architects, engineers, industrial designers. It cost around $1,500, which made it far cheaper than high-end industrial systems like Kata, and it ran on regular personal computers. AutoCAD revolutionized digital drafting, attracting millions because it was simple, powerful, and quickly became the industry standard. By 1986, just 4 years after launch, it was already the most popular CAD program in the world, a position it still holds today. Meanwhile, McNeel, now running RMA with a background in developing automation tools, saw his clients beginning to migrate toward CAD. Around 1985, many of his engineering and consulting customers started asking for help with AutoCAD, because it was rapidly replacing traditional hand drafting. McNeel saw an opportunity, and he moved fast. RMA became one of the largest AutoCAD resellers in the Western United States, and eventually in all of North America. According to McNeel's own history, in the late 80s and early 90s, the company wasn't just selling software. They were supplying hardware, building complete PC setups, and offering training, support, and workflow automation. McNeel even attended local AutoCAD user group meetings, talking directly with real users, engineers, designers, architects, to understand their needs. This made RMA not just a reseller, but a genuine problem-solving partner. But it was exactly at this point that McNeel discovered a major problem. AutoCAD was fantastic for straight lines, 2D drafting, and simple 3D models. But it struggled badly with freeform surfaces, complex curves, and organic shapes. I'm talking about NURBS, a mathematical system for creating smooth, flexible, high-precision curves and surfaces. NURBS had been used in aerospace and automotive industries since the 1950s. Industrial designers, marine designers, aerospace engineers, even jewelry designers were stuck. AutoCAD simply couldn't handle what they needed. Modeling an airplane fuselage or a ship hull required smooth, complex geometry, and AutoCAD was built for precision, but not for freedom. Because of this limitation, users were forced to jump to extremely expensive complex software like Alias or Catia, which cost thousands of dollars and required high-end workstations, not normal PCs. McNeel, who was talking to these users every day, saw the pattern, and he thought, why don't we build a supplemental tool that fills this gap? And that's when Rhino entered the picture, not to replace AutoCAD, but to complete it. Rhino was designed to bring NURBATS modeling to regular PCs, improve workflows, and make advanced freeform design accessible without expensive hardware. In other words, Rhino was born out of a very real market need, an affordable, precise, freeform modeling tool for industries where AutoCAD simply wasn't enough. Section 3, the moment everything changed. The meeting with applied geometry. Now that we've seen how McNeel moved from accounting into the CAD world and identified AutoCAD's biggest weakness, it's time to reach the turning point of the story. The moment that changed everything. Picture this, 1992, Seattle. A city where tech giants like Boeing and Microsoft are on the rise. McNeel and his company, RMA, are now one of the most successful AutoCAD resellers in the region. But the core problem still remains unanswered. How do you bring true NURBS modeling, smooth, complex, freeform surfaces, to regular PCs? And right at this moment, a life-changing encounter happens. A research group from Boeing, known as Applied Geometry, reaches out to McNeel. So who exactly was Applied Geometry? In the late 80s and early 90s, Boeing assembled a team of mathematicians and R&D engineers to work on advanced geometric technologies. As one of the world's leading aerospace companies, Boeing needed extremely precise tools to design aircraft fuselages and aerodynamic surfaces, shapes far too complex for simple lines and arcs. Their solution? A powerful mathematical library called AGLIB, short for Applied Geometry Libraries, the most advanced NURBS toolkit available at the time. NURBS itself wasn't new. The concept had been used since the 1950s in automobile and aerospace industries, pioneered by people like Pierre Bessier at Renault. But in the 90s, everyone wanted it. NURBS allowed designers to model the complex curves and surfaces found in cars, ships, airplanes, and more, with incredible precision. But there was one big problem. Applied Geometry were mathematicians, not software designers. AGLIB was brilliant, but it had no friendly interface, no easy workflow, no tool that everyday designers could pick up and use. And this is where McNeel entered the story. Why him? A few simple reasons. Geography. Both companies were based in Seattle, making collaboration easy. Reputation. RMA was one of the largest AutoCAD resellers in North America and deeply connected to the CAD market. customer expertise. McNeel didn't just sell software, he offered training, automation, and real-time user support. Applied Geometry needed someone who understood real designers and real problems. According to McNeel's official history, the first meeting happened in May 1992, when Applied Geometry visited RMA to discuss integrating AGLIB with AutoCAD. McNeel wasn't a hardcore programmer, but he deeply understood what users needed, and he immediately saw the opportunity. This collaboration became the 0 point in the creation of Rhino. RMA licensed AGLIB and began building a user interface around it, first as a plugin for AutoCAD, and later as a standalone software. This wasn't just a technical partnership, it was a strategic move for both sides. Applied Geometry wanted their math libraries to reach the CAD market. McNeel saw a chance to finally fill the hole AutoCAD couldn't fill. The result? RMA began developing tools that brought NURBS modeling to regular PCs without needing expensive SGI workstations. This partnership was the spark that transformed Rhino from a simple idea into a real product, one that would eventually change entire industries. And interestingly, Although applied geometry was later absorbed into larger corporations, their early collaboration with McNeel laid the foundation for everything Rhino would become. Section 4. The first embryo of Rhino, AccuModel and Sculptura. Now that RMA had partnered with Applied Geometry and licensed the powerful AGLIB library, the team rolled up their sleeves to turn that mathematical engine into something real, something designers could actually use. Their mission was clear: solve AutoCAD's biggest weakness, freeform, curved, and complex surface modeling. The first step was to build a simple plugin for AutoCAD called AccuModel. Imagine this. AccuModel felt like a very technical add-on, great for hardcore AutoCAD users who wanted NURBS capabilities, but the interface was complicated, slow, and not particularly inspiring. It felt more like an engineering extension than a creative tool. McNeel and his team knew, from years of selling AutoCAD, that users needed something smoother, something that truly improved the workflow. But AccuModel wasn't quite there yet. So, alongside it, RMA began developing a completely standalone version called Sculptura. And this one was entirely different. Sculptura didn't depend on AutoCAD. It had a cleaner interface, faster performance, and a full focus on freeform creative modeling. Working with Sculptura felt like shaping digital clay, lofting, sweeping, patching, building those beautiful curved surfaces that designers had been dreaming of. Sculptura became a kind of personal laboratory, giving users full access to AGLIB's NURBS power without any of AutoCAD's limitations. McNeel even attended local AutoCAD user group meetings, showing early previews and collecting feedback directly from designers. Feedback that shaped every decision moving forward. And here's where things got exciting. When the early beta testers, those loyal users who were testing the software for free, finally got their hands on AccuModel and Sculptura, the reaction was explosive. AccuModel was fine. But Sculptura? People loved it. Designers kept saying things like, Sculptura feels more intuitive, faster, and way more like real 3D modeling. One of the developers later admitted, users preferred Sculptura because it felt like sculpting, not like building technical lines and surfaces. That feedback was pure gold. The RMA team quickly made a decision. AccuModel would become less important, and Sculptura would become the foundation of their future tool. And so, the early code from both projects merged together, becoming the first embryo of Rhinoceros. This moment revealed something essential about RMA. They were a user-centered company from day one. Instead of trying to compete directly with giants like Autodesk, they focused on building a complementary, flexible tool that improved real workflows. By this point, thousands of beta testers had already joined the community. RMA realized the market wanted something independent, affordable, and capable of running on regular Windows PCs without expensive graphics hardware or high-end workstations. And that decision was the true beginning of the Rhino revolution, a journey that started with a simple plugin and an experimental standalone, and soon grew into a modeling powerhouse destined to transform architecture, industrial design, and even aerospace. Section 5. Where did the name Rhino come from? Now we get to one of the funniest and most fascinating parts of the story. Where did the name Rhino actually come from? Picture this, it's the early 1990s. The RMA team is working on Sculptura and AccuModel, but the software still has no real name. Everything is temporary, and inside the team, they simply call it codename Rhinoceros, literally a placeholder nickname. The Rhino. But why a rhino? The story goes back to a famous 500-year-old drawing by the German Renaissance artist Albrecht Dürer, titled The Rhinoceros. It's an iconic image of a rhino that Dürer had never actually seen. He drew it based on second-hand descriptions, and the result looked mythical, armoured, almost surreal. Now imagine this. One of the RMA developers, Bill Gillespie, had a print of this artwork sitting on his desk. That strange woodcut rhino slowly became part of the culture inside the office. At first, the name was completely informal, a joke, just an internal code name. But when the beta versions were sent out to the early testers, magic happened. Users loved the name. Why? Because it was different, memorable, and instantly stuck in your mind. While other CAD tools had technical, boring names like CAD this, C3D that, or solid whatever, Rhino felt bold, quirky, alive. Soon, users began sending gifts to the team. Rhino plush toys, mugs with rhinos on them, stickers, magnets, even tiny rhino figurines. The RMA office slowly filled up with these funny little rhino objects, almost like they had built a small personal museum. These gifts were proof of real user affection, and the team realized something important. This name wasn't temporary anymore. Even the very first user manual, written by RMA's technical writer Margaret Becker in 1999, tells the story. We developers called the program a prototype named Rhino. We started collecting Rhino things like magnets and stuffed toys. By the time we released the beta, the name had stuck. We love it. It stands out from CAD this, 3D that, or anything solid. Plus, it makes designing a logo easy. That user manual became a small piece of software history. It showed how a simple joke turned into the identity of a global modeling tool. But the name mattered for a deeper reason. It helped create the digital folklore of Rhino, something the academic articles often refer to. The name gave Rhino a personality. Strong, unique, a little odd, just like the software itself. Capable of handling insanely complex surfaces, yet welcoming to creative minds. Later, this naming style inspired an entire ecosystem. Grasshopper, kangaroo, flamingo, pufferfish, and many more. It was as if Rhino created its own little animal kingdom. Users felt like they were part of a creative tribe, not just using a technical tool. And finally, when Rhinoceros 1 was released in 1998, the name became official Rhinoceros, or simply Rhino. This decision proved something important. RMA didn't just listen to its users in terms of features. They listened in terms of culture. This small story carries a big lesson. Sometimes a simple joke can become the foundation of a revolution. Section 6. McNeel's strange and unusual business model. Alright, now that Rhino is taking shape, let's look at what truly made it stand out. Robert McNeel's unusual, almost rebellious business model. Picture the 1990s, the giants of the CAD industry, Autodesk, Alias, and others, were selling their software for sky-high prices, sometimes over $10,000. Many required complicated hardware dongles. If you lost one, your entire program was locked. And customer support, it felt like hitting a brick wall. Users waited months for bug fixes and had almost zero direct contact with developers. But McNeel? He decided to go in the complete opposite direction. A user-centered, open, affordable model that felt like it came from the future. First, the beta was completely free. Before Rhino's official release, RMA made the beta downloadable online and even mailed CD-ROMs to users. Thousands of people, industrial designers, architects, aerospace engineers, tested the software for free and sent feedback. Today, this strategy is common, but in the 1990s, it was revolutionary. McNeel said, "We want real users to shape the software, not just the developers." The result? By the time Rhino 1 launched in 1998, a massive, loyal community already existed, ready and waiting. Second, direct email access to the developers. McNeel himself answered user emails. Even today, newsletters and update emails still come with the name Robert McNeel, as if he's speaking directly to the community. This level of openness made users feel like friends, not customers. Scott Davidson, RMA's business development lead, later said, "This approach didn't look smart from a traditional business standpoint, but it built trust, and that trust is what made Rhino grow." Third, free open forums for problem solving. From the start, RMA ran Usenet message boards where users shared issues and developers answered directly. Later, this evolved into discourse.mpneal.com, still one of the most open and collaborative communities in the CAD world. No paywalls, no restrictions, just knowledge freely shared. This culture of openness became part of Rhino's digital folklore. Users didn't feel like they were joining a product, they felt like they were joining a tribe. Fourth, no annoying license system. While other CAD tools forced you to use dongles or complex serial codes, Rhino kept licensing simple. Just a basic key, no special hardware, no expensive workstation required. McNeel insisted, Rhino must run on ordinary Windows desktops and laptops, no special hardware. This accessibility democratized advanced 3D modeling. And finally, the price. The professional version was $795 and the student version only $195. Compare that to Alias at over $10,000. Rhino instantly became one of the most affordable NURBS modelers in the world. In the first user manual, Margaret Becker wrote, "Rhino is designed to be affordable and accessible, to bring freeform modeling to PCs without trying to replace existing CAD tools." This low cost brought Rhino into architecture schools, small design studios, and even hobbyists' homes, places where other tools never had a chance. This culture had no equivalent in the CAD industry of the 1990s. RMA stayed a small, privately owned, employee-owned company. They never sold out to the giants. McNeel prioritized the community over maximizing profit. And the result? An open ecosystem that later produced free tools like Grasshopper, which completely changed digital design. This wasn't just a business model, it was a cultural revolution. McNeel proved that software could be for the people, not just for the profit of corporations. Section 7. The first big name, Frank Gehry. Now that Rhino had its quirky name and revolutionary business model, let's get to the moment that shook everything. The release of version 1 in October 1998. Imagine this. After years of beta testing and thousands of loyal users, Rhino was finally official, a powerful, affordable NURBS modeling tool running on Windows NT, requiring no special hardware. But who was the very first big purchaser? Frank Gehry. Yes, the legendary architect himself. Pulling out his credit card right on day one. Scott Davidson, RMA's business development lead, said in an interview, "We got Frank Gehry's credit card on the very first day. This was like a bomb going off. Gehry wasn't just a high-profile first buyer, he proved the enormous potential of Rhino." So why did Gehry fall in love with Rhino? In the late 90s, Gehry was building his signature style from physical models, complex, curving sculptures that then needed to be digitized. NURBS was the perfect tool. Gehry would use 3D scanners to capture points from his physical models, then employ commands like patch, loft, or sweep to create precise digital surfaces. Rhino made this workflow seamless. Files could be exchanged between formats, It was compatible with hardware like scanners, and its interface resembled AutoCAD, which Gary's designers were already familiar with. The first user manual even explained, you can digitize physical objects using specific commands to record 3D points, draw 3D curves, and construct surfaces directly from physical models. For Gary, Rhino was a game changer. It helped turn visionary projects like the Guggenheim Bilbao from concept to reality without the usual software headaches. Here's the twist. RMA hadn't even built Rhino for architecture. Their target industries were aerospace, marine, jewelry, consumer goods, medical devices, sports equipment, and even footwear. Architecture wasn't on the radar. The first manual, written by Margaret Becker, notes, Rhino is used in marine, aerospace, and automotive interior-exterior design. Manufacturers of household goods, furniture, medical devices, sports equipment, footwear, and jewelry use Rhino for free-form shapes. Davidson said, no one was like Gary, we thought he was the only architect interested. At the time, architecture still focused mostly on straight lines, and NURBS was considered mainly an engineering tool. Aerospace professor David F. Rogers even wrote in 2001, NURBS are ideal for designing cars, airplanes, ships, shoes, shampoo bottles, and Hollywood animation characters. No mention of architecture. Yet, Gary's purchase opened a whole new door. Gary and his team at Gary Partners brought Rhino into the world of architecture, demonstrating that it could transform physical models into digital forms and production-ready files. This moment elevated Rhino from an industrial tool to an architectural superstar. From there, avant-garde architects started using it, and Rhino became central to the emerging wave of parametric design. This story shows how a single purchase can change the trajectory of software, from aerospace labs to skyscrapers. And now, get ready for the rise of a new generation, parametric designers, and the birth of Grasshopper, where Rhino truly went global. Section 8. The rise of parametric designers and Grasshopper. Now that Rhino had entered the architectural world with Frank Gehry, it's time to reach the climax of the story. The rise of a new generation of designers and the birth of the tool that changed everything. Imagine the mid-2000s. Architects and designers were using Rhino to create complex surfaces, but parametric design was still mostly for programmers. Heavy coding, complex scripts, and deep computational knowledge were required. Then, in 2007, a key figure emerged, David Rutten, a creative designer programmer at RMA. He saw beyond simple modeling and realized that Rhino needed something to democratize computational design, to take it out of the hands of elite programmers and put it into the hands of everyday architects, students, and hobbyists. What did he create? Grasshopper, a visual programming language for parametric design. Initially known as Explicit History, it soon became Grasshopper, a free Rhino plugin functioning like a live, interactive graph. Picture this. Instead of writing thousands of lines of code, you drag and drop components, connect them, tweak parameters, and see everything update in real time. Create a curve, loft it, change its angle with a slider, and watch the surface transform instantly. Grasshopper made algorithmic design accessible, from physics simulations with Kangaroo to optimizing forms for fabrication. Rutten explained, I wanted to create a tool where users could build their own tools without needing to be programmers. The result? Grasshopper launched with Rhino 4 and has evolved through Rhino 8, now boasting millions of users worldwide. This birth sparked a global movement, forming parametric designers and digital fabricators. This new generation can control forms with data and algorithms, sending models directly to CNC machines or 3D printers. From there, Smart Geometry, a pioneering group since 2009, offering workshops and seminars on parametric design and scripting. AGLIB, International Association for Computational Design, highlighting Grasshopper as a key tool in conferences and workshops. AGLIB, Advanced Geometry Unit at AGLIB, using Grasshopper for large-scale projects like stadiums and bridges. Grasshopper 3D communities, forums and discourse platforms where thousands of users share ideas, scripts and components, turning Rhino into a global design language. Together, Rhino and Grasshopper transformed the role of the architect from a traditional designer to a creative technologist. A rich community of practice and folklore emerged. Projects that were impossible without these tools became the new standard. Zaha Hadid architects, Aidas, and others used Grasshopper to design parametric facades, dominating digital architecture from the mid-2000s through the 2010s. Grasshopper wasn't just a plugin, it was a revolution. It moved design from static to dynamic and spawned a new generation of parametric designers who continue to shape the world today. And now, let's return to the rhinoceros culture, where Rhino created its own tribe. Section 9, the Rhino culture, tribe, folklore, myth. Now that Grasshopper had spawned a new generation of designers, it's time for one of the most fascinating parts, the Rhino culture. Rhino wasn't just a software, it created a tribe, a digital folklore with its own values, rituals, and even myths. In the early 2000s, as architects grew weary of critical theory and shifted toward computational creativity, Rhino became a symbol of this change. Its users acted like a real tribe, with leaders, rituals, and a sense of belonging that went beyond code and modeling. The interesting part? This culture emerged from non-professionals and hobbyists, not just elite hackers. Knowledge spread through forums, workshops, and shared projects. Bottom up, not top down. One charming feature of this culture was the animal-inspired names that made everything fun and unique. Grasshopper for parametric design, Kangaroo for physics simulation, Ladybug for environmentric analysis like sunlight and wind, Pufferfish for complex transforms, Flamingo for rendering, and others like Honeybee, Peacock, and Millipede. All these names drew inspiration from Rhino itself, a strong yet friendly rhino that created its own animal ecosystem. This naming tradition set Rhino apart from dry software like SolidWorks or CATIA, and strengthened the sense of folklore. Users felt they were part of a creative zoo, where every plugin added a new animal. The tribe had its myths and leaders too. Robert McNeel, founder of RMA, became a legendary figure like a tribal shaman, protecting values of openness, affordability, and knowledge sharing. Technical leaders such as David Rutten, father of Grasshopper, and Daniel Piker, creator of Kangaroo, acted as the chiefs of the tribe. They ran workshops, shared scripts, and guided users. Global communities and meetups were part of the culture. From the early Usenet boards to today's discourse.mneel.com, users shared problems, uploaded scripts, and held local meetups like the NYC Rhino meetup in 2014, featuring simple invites and fun emojis. The culture of freely sharing scripts is a masterpiece. Thousands of free components are available on grasshopper3d.com, where anyone can create and share their own tools. This culture is what truly set Rhino apart. While companies like Autodesk focused on profit and market dominance, RMA remained employee-owned and prioritized community. This culture became like tribal knowledge. With ideology and faith, users were loyal to Rhino, almost like choosing a religion. The result? A digital folklore that introduced new words and concepts like booleaned or photoshopped into architectural language, and even inspired manifestos about parametricism. And the Rhino culture is still alive today, from the early Rhino-themed gifts to modern online communities. Rhino proved that software can create culture, not just models. Section 10. Why Rhino was made. Now that we've walked through the entire story, from an accountant passionate about automation to a tribe of parametric designers, it's time to return to the heart of the matter. Why was Rhino made? Rhino wasn't the product of a wild fantasy or a massive investment. It was born out of a real and urgent need, a need rooted in the CAD industry of the 1990s. Imagine a world where designers were stuck with complex, curved surfaces. AutoCAD was excellent for straight lines, but when it came to NURBS, freeform, precise geometry, everything became slow, expensive, and restrictive. McNeel and his team saw that real users, from aerospace engineers to industrial designers, needed a tool that allowed free, accurate, and manufacturable design without emptying their pockets or requiring giant machines. Rhino was built to solve problems that other methods couldn't. A complementary tool to improve workflows, not replace existing CAD. So, what was the core problem? Designing freeform complex geometry that was both precise and buildable, but with a tool that, one, was affordable. While software like Alias cost over $10,000, Rhino launched at $795 for professionals and $195 for students. Affordability was the key to democratizing access, moving users from expensive SGI machines to everyday PCs. 2. Ran on regular computers. No special graphics card required, just Windows NT on standard desktops or laptops. This shift from industrial workstations to personal computing sparked a digital folklore. 3. Was built for real users. McNeel's experience selling AutoCAD taught him that users needed friendly, intuitive tools, not complex ones. Rhino evolved with direct feedback from beta testers. This was a shift in modes of working, where designers became creative technologists, not just draftsmen. 4. Had accountable developers. Direct email, free forums, and an employee-owned company that prioritized the community over profit. McNeel became a mythical figure, always listening. The result? Software that grew with user needs. 5. Could connect to any new technology, from 3D scanners and CNC machines to plugins like Grasshopper. Rhino was an open platform. This enabled the intelligence of fabrication, where design directly fed manufacturing. Rhino wasn't a dream, it was a real solution. Simple access to a precise, freeform modeler that allowed architects, designers, and engineers to create without limits. It transformed how people worked and learned design, from an accidental collaboration with Boeing to a full-fledged cultural revolution. Emotionally, Rhino was a people's hero. Against expensive giants, it was humble yet powerful, saying, anyone can build. It didn't just change architecture, it inspired a generation to embrace technology as part of their creativity. Now, it's time to close this story and reflect on the final message, a message that still continues today. Now that we've taken this exciting journey together from a simple accountant in the 1980s to the parametric revolution of the 2000s, let's end with a powerful, emotional message. The story of Rhino is the story of a small, passionate team at RMA who, unlike software giants like Autodesk or Alias, decided to create a tool that people truly needed, not from expensive university labs, not from big Hollywood venture capital, but directly from the heart of the user community. A software that prioritized practical intelligence, not just profit. McNeel and his team, with their employee-owned, user-focused approach, showed that technology can be humble and accessible without losing its power. Today, every complex project you see, from parametric skyscrapers to sustainable structures, carries a trace of Rhino and Grasshopper behind it. For example, Guggenheim Bilbao by Frank Gehry, Harbin Opera House by Emad Architects, Morpheus Hotel in Macau by Zaha Hadid Architects, even the Istanbul Radio Tower. All of them use the power of NURBS and Grasshopper scripting to turn wild ideas into reality. These tools didn't just enable curved forms, they created a global culture of building with data, from small studios in India and China to large offices across Europe. Rhino created two new types of architects, parametric designers and digital fabricators, who are still pushing projects like vertical tides and minima forward. And the story is far from over. Rhino 8, with AI features and connectivity to new technologies like VR and 3D printing, proves that this old Rhino is still evolving. If you take one thing from this story, let it be this: real technology comes from everyday needs, not from the top down. Now it's your turn. Open Rhino, create a model, and become part of this tribe. Thank you for joining us. Don't forget to like and subscribe, and until the next video, goodbye.